Good morning. In this unit one, we are going to see uh, in this block and we are going to see unit three. The unit three is nothing but what means a graphical method of solutions and simplex method. That is already what we have seen in the last unit, forming the linear programming problem. For that, already we have framed the linear programming problem in the last unit itself, and that linear programming problem, we have to find the solution by means of graphical method and also by simplex method. So there are two ways to find the solution. One is nothing but the graphical method, another one is nothing but the simplex method. Here we are having the objective and introduction, working procedure for graphical method, worked out examples, working procedure for simplex method, worked examples, and also sum up for this unit and keyword and terminal questions regarding this unit. All these things we are going to see now. The main objective for this unit is that is you have to find out the graphical solution, that is solution by means of graphical and simplex method. After studying this unit, we will be able to formulate the linear programming problem and identify its characteristics and make a graphical analysis of linear programming problem and solve the problem graphically. We can solve this problem by the graphical method. Moreover, we can understand the basics of simplex method and also the various solutions obtained by using simplex method. Next, introduction. Introduction for this graphical method is a graphical method that provides a pictorial representation of the problem. That is all the constraints. Already we have studied in the last unit itself how to frame the constraints. That is the constraints are represented by the pictorial form. That is graphically we can represent the conditions and their solution as well as the basic factors involved in solving general LPP involving any finite number of variables. So if you are having more decision variable, we can solve. And for finite, everything is same thing only. We can solve the finite number of decision variable used in the LPP and may effectively solve LPP involving only two variables. Next, actually the graphical method is applicable only for two variables, but the simplex method means any number of variables we can use it. The linear programming problem with two variables can be solved graphically. The graphical method of solving linear programming problem is of limited applications in the business problem as the number of variables is substantially larger. So if we are having only two variables, x1 and x2 means definitely we can solve that equations by using the graphical method. If the linear programming problem has large number of variables, more number of variables means then any suitable method for solving this simplex method. That is, if you are having 3 variable, 4 variable means we can solve that by using the simplex method. Therefore, the simplex method is an iterative process through which it reaches ultimately to the minimum or maximum value of the objective function. That is, we can find the objective function. That is, either we can maximize or minimize the objective function by the iterative process of the simplex method. So this is the basic thing there. Iterative method means till we reach the answer, we have to proceed the same part. We have to proceed with the same operations. That is the meaning for an iterative process. Next, working procedure for graphical method. In graphical method, we are having some procedures. What are all the procedure means? Initially, we have to consider the inequality constraints as equality. That is, all the inequalities, either it is less than or equal to or greater than or equal to, should be converted in terms of equal to. So all the inequalities should be converted in terms of equalities, and in the XOY plane, draw the straight lines that corresponds to each equality and non-negative restrictions by putting x1 equal to 0, we get x2, and x2 equal to 0, we get x1. That is, if you are putting, that is, you should get the coordinate set. Coordinated set. Coordinated set means xy. Here it is nothing but x1, x2. So if you are putting x1 equal to 0 means we can get the value for x2. Similarly, if you are putting x2 equal to 0 means we get the value for x1. So some set of coordinates we will be having. That coordinates we have to represent it by the straight line. Next step is you have to find the bounded region for the variable values which is the region bounded by the lines established in step one. That is, whatever may be the coordinate, we have to draw that as a straight line. That is a thing we have to do in the step two. Next thing is step three means you have to find the point of intersection of the bounded lines. In the bounded line, if there is any intersection part means you have to solve that lines. We have to solve that lines that corresponding equations and substituting we'll be getting the objective function to get the values of the objective function. That is, whenever we are crossing any two straight lines means you have to find out that point of intersection. That is a meaning there. And for maximization problem, the maximum value of z is the optimum value. For minimization problem, the minimum value of z is the optimum value. So whatever the thing, if it is maximization means maximum, minimization means minimum. So these are all the steps we have to follow for framing the graphical method. And by graphical method also, we'll be getting the value for the objective function. Now we can see the worked out examples. What they have given you here. Here, solve the following linear programming problem using graphical method. You have to solve this one by using the graphical method. How can we solve this? By using the graphical method that we are going to see now. So what is the objective function? Already in the last unit, we have studied about the formulation of the linear programming problem. But here we are already having that formulation. You have to solve this. That is our aim here. That is, already we have framed the linear programming problem. And in this one, you have to catch, which is your objective function. Objective function is the first statement. That is, maximize z equal to 3x1 plus 2x2. This is the objective function. Subject to some conditions they are given. That is, minus 2x1 plus x2 less than or equal to 1, x1 is less than or equal to 2, x1 plus x2 is less than or equal to 3, and x1, x2 greater than or equal to 0. So generally the last step will be given for all the problem because all are non-negative integers only. Here the decision variables is nothing but x1 and x2 alone. So what the decision variables we are having here means x1 and x2. Our aim is to find the value for our x1 and x2. So this is a thing we are going to see here. And then here, now we can consider the inequality constraints as equality. So initially, what is the thing you have to do it here means you have to convert all the inequalities as equations. So what is our first equation? Minus 2x1 plus x2 less than or equal to 1. So that less than or equal to, here we are seeing less than or equal to, this less than or equal to are converted into equal to without changing any symbols. So what's the thing you will be having? Minus 2x1 plus x2 equal to 1. In this equation, if you are putting x1 equal to 0, if you are putting x1 equal to 0, you will be getting x2 equal to 1 directly. And we can represent that coordinates as 0, 1 because the first place is for x1 and the second place is for x2. So we can get the coordinates as nothing but 0, 1. Similarly, if you are having x2 equal to 0, you will be getting, you substitute your x2 equal to 0 here. What the remaining thing you will be having? Minus 2x1 equal to 1 or x1 equal to minus 1 by 2. Minus 1 by 2 means it is nothing but minus 0.5. So this is the coordinate you will be getting if you are putting x2 equal to 0. So you will be getting minus 0.5 comma 0. So what is the first coordinate we are having here means 0 comma 1. Another one second coordinate what we are having here means 0.5 comma 0. So this is the thing we are having. And what is our, this one, x1 is less than or equal to 2 is a simple equation. So if you're putting inequality as equality means you will be getting x1 equal to 2. So you can simply draw a line. Simply draw a line means your line will be like this. In the place of x1, actually this x-axis is nothing but x1 and this y-axis is nothing but x2. In this x1, in the place of 2, you can draw a straight line. In the place of 2, you can draw a straight line and that is nothing but what means x1 equal to 2. And what is the next equation we are having here means x1 plus x2 is less than or equal to 3. x1 plus x2 is less than or equal to 3. If you are converting that one as equation, you will be getting x1 plus x2 is equal to 3. So if you are putting x1 equal to 0, in the place of x1, if you are putting 0 means you won't be getting this x1. you will be getting only x2 equal to 3. So directly you will be getting the value as x2 equal to 3. So what is the coordinate here means 0, comma 3 because the first place is for x1 and the second place is for x2. Similarly, if you are putting x2 equal to 0, you will be getting x1 equal to 3. So what is the coordinate you will be having here means 3 comma 0. So you are getting another two coordinates also here. So actually how many coordinates we are having here means here we are having 0 comma 1 minus 0.5 comma 0. There is two coordinate here and remaining two coordinate what we are having here means 0 comma 3 3 comma 0. So all these things you have to represent it in the all these things you have to represent in graphical method means in the graph only we have to draw. So you just consider this one as a graph because we won't be focusing the graph here in this picture. We are just imagining and we are plotting ourselves. So what is the thing we are having here means already we know this line is nothing but the x-axis and this line perpendicular to this one is nothing but the y-axis. But here we can have this one as what means x1 and here we can have it as what means x2. And we can plot that given coordinate. That is given coordinate means the coordinate what we have obtained. We can plot that one and then we can see which is the feasible region for you. So what is the thing we are having here means first coordinate is 0, 1. Another coordinate is minus 0.5 comma 0. So 0 comma 1 means where you will be getting the 0 comma 1. Here if your x1 is 0, all this thing here is your x1 equal to 0. This x2 line is simply x1 equal to 0 only. So x1 equal to 0 is here and in the place of x2 you will be having 1. So this is your 1 here. So this coordinate you can mark it as what means 0 comma 1. You can identify that where I am placing the cursor. Similarly, the next thing is minus 0.5 comma 0. Minus 0.5 comma 0 means in your x-axis you can place the value for minus 0.5. This negative part we can place it in the left hand side minus 0.5. 0 is this full line is x2 equal to 0. So this is nothing what means minus 0.5 comma 0. So this line is that is this coordinate is and this two coordinates you can have mark it as a straight line. You can join this two coordinate and you can mark it as a straight line and above the line you can name what is the equation that is minus 2x1 plus x2 equal to 1. That is you can name what is the equation we are having here. So this is a straight line we obtained by joining the two coordinate and above that line you can write what is that equation is telling there. So this is a first straight line. And what about your next coordinate means the next coordinate is nothing but 0 comma 3 and 3 comma 0. So 0 comma 3 means if your x1 equal to 0 and your x2 value is 3 where you will be getting this point 0 comma 3 and 3 comma 0 means you will be having 3 comma 0 and you can join this two coordinate and you can name that coordinate by marking the line x1 plus x2 equal to 3 because from that line only we had the coordinates from that straight line only, that is from that equation only we have got the two coordinates. So you have to write it on the top of that line, that is x1 plus x2 equal to 3 and you can identify that both the equations are less than or equal to. Here we are having first equation is also less than or equal to, second equation, this equation, everything is less than or equal to. So everything you have to mark inside the boundary of that line. That is we can shade that inside the boundary of that line. That is in this line inside the boundary, this line inside the boundary, and we can shade the region common to this both the lines. Inside the boundary means you should not move above the line, and here also you should not move above the line. So inside the region, which part is common for both the straight line, that you have to mark it up. Which part is common for both the lines? Which part is common means this downward part. Here they have marked. Here they have marked the lines they have drawn. No, this line is. These lines are common for both the straight lines. If you are taking this part means it won't be applicable. But if you are taking this part means it would be applicable somewhat. So because This part, if you're taking, means there is no connection for this straight line minus 2x1 plus x2 equal to 1. So there is no connection for that region. That is for that straight line. So for that only, we are not considering this one. We have to consider only this part. So in this part, we are getting the common region, and this common region is nothing but the feasible region. But we don't know the coordinate here. That is this point of intersection we have to identify. The point of intersection we have to identify, because this coordinate you know, this coordinate you know, this coordinate you know, but this coordinate, that is this point of intersection, we don't know. So how do we identify that point of intersection? Means you have to solve this two straight line equation, minus 2x1 plus x2 equal to 1 and x1 plus x2 equal to 3. If you are solving the two equation, you will be getting that value as 2 comma 0. That point means you will be getting the value as 2 comma 0. Now we can move here. The feasible region is also known as the solution space of the linear programming problem. Every point within this area satisfied by all the constraints. That is, if you are shading this region, means all the conditions are satisfied in the shaded region. That you have to keep it in our mind. In the shaded region, all the conditions must be satisfied. So you see here, all the conditions are having the inequalities as less than or equal to only. So less than or equal to, less than or equal to, everything is less than or equal to only. So the less than or equal to is line below that. So that line what you have drawn below that region only you have to shade, and in that shaded part you have to identify which is the common for part for both the straight lines. So we have to view that one, and if there is any point of intersection also, you have to find it out, and then only we can move for the problem. So what are all the vertices we are having here? What are all the vertices we are having here? Means 0 comma 0. Another one is 2 comma 0. Another one is 2 by 3 comma 7 by 3. Another one is 0 comma 1. All these, everything we can take it as our vertices. Already how many vertices we are having? How many coordinates we are having? 0 comma 1 minus 0.5 comma 0, and another one is 0 comma 3 3 comma 0 we are having. And within this feasible region, you have to identify what are all the coordinates we are having. So within this feasible region, what are all the coordinate we are having? Means 0 comma 1 is one part. Okay, and here you will be having 2 by 3 comma 7 by 3. Another one is 2 comma 0. 2 comma 0 means this line. Here if your x1 is 2, x2 will be equal to 0. That is nothing but a straight line, but they didn't draw that a straight line. But that straight line is nothing but 2 comma 0. So this point of intersection is 2 by 3 comma 7 by 3. And another point is 0 comma 1. Here we are having. So four coordinates we are having. 1, 2, this one is 3, and this point of intersection is 4. 2 by 3 comma 7 by 3, and 0 comma 0 is common for all the problem. 0 comma 0 you can do for all the problem, and all these 4 points where you have to substitute it there, means you have to substitute in this function. Where you have to substitute means you have to substitute in your objective function. What is your objective function? Maximize z equal to 3x1 plus 2x2. In this objective function, what are all the coordinates we have selected? What are all the coordinates we are having in our feasible region? That is, what are all the coordinates we are having in the shaded region? That you have to substitute it there. That is, if you are substituting 0 comma 0 means your x1 is 0 and x2 is 0. x1 0, x2 is 0. So what you will be getting in this equation? x1 is 0 and x2 is 0 means 3 into 0 plus 2 into 0 will be 0. So your maximum z equal to 0. Another one is 2 comma 0. Your x1 is 2 and x2 is 0. So x1 and the 2, x2 and the 0 now. What you will be getting? 3 into 2 plus 2 into 0. So 2 into 0 will become 0. 3 into 2 will become 6. So that value only you have to write it. And then 2 by 3 comma 7 by 3 means 20 by 3. 0 comma 1 means it is nothing but 2. Among this, which is the maximum value, which is the highest value, means only 6 is the highest value. Therefore, we can solve the problem. Maximum z value is nothing but 6, and the corresponding decision variable value is x1 value is 2 and x2 value is 0. So this is a graphical method of solving the conditions. This is one of the way of solving the constraints by using the objective function. So this is the first example. Next, the same LPP problem can be solved by using graphical method. graphical method. But the thing what you have to do it in your objective function is minimum is equal to 4x1 plus 2x2 subject to x1 plus 2x2 is greater than or equal to 2. 3x1 plus x2 less than greater than or equal to 3. 4x1 plus 3x2 is greater than or equal to 6. All these three are the three conditions we are having here. So what are all the, if you're seeing the conditions, everything is containing what means greater than or equal to symbol only. So all the three equations are containing the value as what means are greater than or equal to. So all these things we have to convert it in terms of equality, that is equal to conditions. So how can you consider the inequality as equality means like this? That is first equation, x1 plus 2x2 equal to 2. That greater than or equal to symbol you just take down. Less than or equal to symbol you take down. So if you're putting x1 equal to 0, if you're putting x1 equal to 0, you'll be getting 2x2 equal to 2 or x2 equal to 1. So the coordinates are 0, 1. Similarly, if x2 equal to 0 means you'll be getting x1 equal to 2. So you'll be getting 2, 0. So two coordinates you are getting. Similarly, for the second equation, if you are having 3x1 plus x2 equal to 3 means you will be having, if you are substituting x1 equal to 0, you will be getting x2 equal to 3. So that coordinate is nothing but 0, 3. Similarly, if your x2 equal to 0 means x1 equal to 1, you will be having the coordinate as 1, 0. Similarly, the third equation we are having 4x1 4x1 plus 3x2 equal to 6 means if you are putting x1 equal to 0, you will be getting if 3x2 equal to 6 or x2 equal to 2. The coordinate is 0, 2. Similarly, if your x2 equal to 0, you will be getting the value for your x1 equal to 1.5. Therefore, the coordinates are 1.5, 0. So how many coordinates we are having here? We are totally having 6 coordinates. First one is 0, 1, 2, 0 for the straight line x1 plus x2, x2 greater than or equal to 2. Similarly, for the second coordinate, you will be having 0, 3, 1, 3, that is 1, 0. For the equation 3x1 plus x2 is 3. And similarly, for 4x1 plus 3x2 equal to 6, we will be having the coordinates like this. All these coordinates we have to plot it by using the graphical method. So what is our graphical method here means, if you can draw a diagram like this, that is marking 0, 1, 2, 3, 4, 5, 6, because there is no negative value, I think so. So everything we can mark it like this. And what are all the things we are having? See, first coordinate is 0, 1, 2, 0. So 0, 1 and 2, 0, we can have it like this. 0, 1, 2, 0 means this line, 2, 0. So, and we can draw a straight line, and we can draw a straight line. Similarly, for other values also, we can draw a straight line, and we can mark which region is common for all. Which region is common for all, we have to mark it, and the shaded region is common for all. So the feasible region is nothing but the solution space, and in the solution space, we are getting all the regions as common. We are getting all the regions as common, and this region is said to be called as a feasible region. And in this feasible region, you can see what are all the coordinates we are having. That coordinate we have to take it and write it here. So what are all the coordinate we are having means, initially we are having a 0, 0, 0, 1, 1, 0, and this point of intersection you have to find it out. That is nothing but 0.8, 0.6. So this point of intersection we have to take it. All these four values you have to take and substitute in our objective function. So what is our objective function? What is our objective function means minimize is equal to 4x1 plus 2x2. In this objective function, you have to substitute the value for our coordinate what we have got. So what are all the values we have got here means 0, 0 means you'll be getting 0, 0, 1 means 2, 0.8, 0.6 means 4.5, 4 and 1, 0 means it is nothing but what means 4. So these are all the values we have got it, and actually the problem is based on minimization. So minimization means you have to see which is the minimum value here. What is the minimum value here? Among the four values means the minimum value is 2. So according to that, what is corresponding x1, x2, you just see the corresponding x1 value is 0, and the corresponding x2 value is 1. So this is the thing we are doing here by using the graphical method. So all the two problems what we have seen so far is nothing but the graphical method of finding the solution for the objective function. You have to make all the inequalities as equalities and you have to get some coordinate, and that coordinate you have to draw it in the straight line format and mark what is that line actually, and you have to find which region is common for all. If you are finding that region means you see what are all the coordinates we are having there, on that coordinate you, for that corresponding coordinate we can find the maximization or minimization model. Everything we can find it out, either maximization or minimization. Now maximization means among the table value you have to see which one is by a big value. Minimization means you have to see which one is the smallest value. That's the thing you have to do for our graphical method. The next thing is we have to see the that is a solution for objective function by using the simplex method. So simplex method is the another method for solving two or three variables. If you are having four variables also, you can solve that one by using the simplex method. So that is the main advantage here we are having. Here, step one. What is the thing you have to do it for us? Step one means what is the thing you have to do it for us? Step one means check whether the objective function. You have to identify whether the objective function is minimized or maximized. If it to be minimized means then convert into maximization type. So if you are having it in minimization means you have to convert into terms of maximization. So minimize z equal to minus maximization of minus z. So you will be getting maximization here. So all the type of minimization problem also must be converted in terms of maximization. So that is the first step you have to do. And check whether all the RHS are positive, all the right hand sides are positive. If any one of the RHS is negative, that is if any one of the variable in the right hand side is negative, then multiply both the side of the constraint by -1. That is if you are having any negative value also, you have to multiply it by -1. Everything can be converted. Then multiply both the side by constraint -1, then all the type of equation will be converted. And then convert inequality into equality constraint by introducing slab or surplus variable. That is, we are having the constraint as greater than or less than format means you have to convert in terms of equality type. That is, if you are having any inequality type means all the things must be converted into equality type. And then in the initial simplex table, if you are having like this, that is the table, how to frame here by for the simplex method is like this. In the simplex table, if you are taking x1, x2 equal to 0, so that xz equal to 0, and simplex method table will be like this one. Simplex method table will be like this means actually you have to frame like this. That is, you have to mark CB, YB, XB, X1, X2, X3, S1, S2, S3, everything like this. Actually, this X1, X2, X3 are nothing but the basic variables. That is decision making variable. Already we have seen in LPP. And this X1, X2, X3 are nothing but the slag or surplus variable. Slag variable means when you are having less than or equal to symbol. That is, if the quantity is less means you have to add. So the quantity less means you have to add means you will be having the slag variable. If the quantity is more means you have to reduce that one. Then we have to use our surplus variable. That is, surplus variable means minus S1. So slag means if you are having more quantity means you have to reduce. Surplus means if you are having more quantity means you have to subtract. So that's the thing you have to do it there. And this is a basic structure for our simplex table. The structures we can identify while we are doing the problem. So CJ, in that CJ, what are all the things we are having here means C1, C2, C3. We can mark that while we are doing the problem. And Cj denotes the coefficients of the variables in the objective function. Cb means column denotes the coefficient of the basic variable in the objective function. And Yb means column denote the basic variables. And Xb means column denote the variable, that is the values of the basic variables. Here in this one also, we can compute the net value of Zj. That step 4 can be identified very well if you are doing the problem. If you are simply seeing here the format also, we can't understand somewhat. But if you are doing the problem, somewhat we can understand how to formulate the table there. And then in the step 5, you have to complete the, that is you have to compute the net evaluation. What is our net evaluation means? For the Zj minus Cj we are getting, we have to see what is our net evaluation value. So we have calculated some value for Zj minus Cj, and that value you have to see. If it is greater than or equal to 0, means the current basic solution is optimal. Otherwise, if it is not optimal, we have to go for the next step. And find the entering variable means if more than one variable has some same most negative value, means any of this variable may be selected arbitrarily as the entering variable. This entering column is also called as a key column or pivot column. That is, key column or pivot column means the value that corresponds to the most negative value. That is the thing we have to take it for our key column or pivot column. And step 7 is to find the leaving variable. Step 7 to find the leaving variable means the ratio between the solutions column and the entering variable column by considering only positive denominators. And it is defined by theta equal to minimum of xbi divided by AIR. And if AIR is less than or equal to 0, we will be getting the unbounded solution of the given problem. The leaving variable now is called the key row or pivot equation, and the element at the intersection of the pivot column and pivot row is called the pivot element. The pivot element we can identify if you are framing the table. That is, the row point of intersection of the pivot column and pivot row is nothing but the pivot element. And step 8 means you have to drop the leaving variable and introduce the entering variable along with its associated value under CB column. That new pivot element can be that is formulated as old pivot element divided by the pivot element, or otherwise the new equation is equal to old equation minus corresponding column coefficient into new pivot equation. So these are all the ways. But if you are seeing also, somewhat only we can understand. But if you are doing the problem very well, we can understand what's the thing we have to do it there. So the last step is you have to go for step 5. If you are not getting any proper value, means once again you have to go for what means step 5 and repeat the procedure until either an optimal solution is bounded or there is indication of an unbounded solution. So if you are getting a value from the step 8 directly, means we can stop the problem. If we are not getting any value, means you have to go once again for the previous step, and then you have to see it in the you have to repeat the procedure 1 to 8 once again. And these steps, the steps regarding the simplex method, what we are having here are well identified if we are doing the problem. So if you are doing any one problem or two problem, means we can identify the steps what it is given there. So for maximization type, if all the Zj minus Cj is greater than or equal to 0, means the current basic feasible solution is optimal. We can say that the basic feasible region is optimal. So if at least one Zj minus Cj is less than 0, means the current basic feasible solution is not optimal. And the entering variable in the non-basic variable corresponds to the most negative value, means we have to see further. And then for a minimization type, means this greater than or equal to must be converted into less than or equal to. So if Zj minus Cj is less than or equal to 0, means then the current basic feasible solution is optimal. If at least one Zj minus Cj is greater than 0, means then the current basic feasible solution is not optimal. So you have to frame what means vice versa. Whatever it is giving for maximization type, the opposite to that one will be for the minimization type. So the vice versa characteristics only we have to frame it here. And we can see some example. By seeing this example, we ourselves can identify the steps, what they have given there clearly. So what is the thing first we are having here means you have to solve the following linear programming problem using simplex method. So by using the simplex method, you have to solve this problem. So what is this problem actually? Actually means maximize z equal to 21x1 plus 15x2 subject to the constraints minus x1 minus x2 is greater than or equal to minus 6. 4x1 plus 3x2 is less than or equal to 12 and x1 comma x2 is greater than or equal to 0. So actually this is nothing but what means this is the basic variables involved in these equations are x1 and x2. So you have to find the value for this one. Actually, we can find the solution for this one by using the graphical method also. But here we have to solve this equation by using the simplex method. So we can see how it would be the solution in first inequality and then negative, you are having the negative with the 6. So we have to multiply both sides by the constraint by minus 1. So if you are multiplying both sides of the equation by minus 1 means what's the value you will be getting? X1 plus x2 is less than or equal to 6. Or we can make it as equal to 6 also. Equal to 6. And then the second equation is quite okay. We are having 4x1 plus 3x2 is less than or equal to 12. And then here, step 2 is nothing but you have to introduce the slag and surplus variable. Actually, this less than or equal to we have converted into equal to model. So you have to introduce that is we have to introduce only the slag variable x1 and s1 and x2 in the standard form. So that is already with this equation throughout we have multiplied by minus. So this equation had been converted into x1. This minus had been converted into plus x1. This minus 2x2 had been converted into plus x2. And this minus x had been converted into plus x. So this less greater than or equal to had been converted into less than or equal to. So if you are having less than or equal to means you have to introduce the slag variable. That is you have to add. If you are having less quantity means you have to add. More quantity means you have to subtract. So that is our basic factor. So this less than or equal to if you are having means you are adding plus S1. If similarly, the second equation is also less than or equal to, the less than or equal to means if you are having less quantity means you have to add means you have to introduce the slag variable S2. So this is a first slag variable S1 and the second slag variable S2. So what's the thing we are having here means if you are having less than or equal to symbol means you have to add. If you are having more than or equal to means you will be having minus S1. In case if you are having greater than or equal to all the equations means you will be having minus S1, minus S2, likewise you will be having. And then you have to introduce these two slag variables in our objective function also. What is our objective function? 21x1 plus 15x2 plus 0s1 plus 0s2. This thing you have to introduce for our objective function also. So this is the thing you have to do it here. And step 3. What is our step 3 means? You have to put x1 equal to and x2 equal to 0 in equation 1 and 2. We will get the initial basic feasible solution as s1 equal to 6, s2 equal to 12. That is in this two equation. If you are assuming x1 and also an x2 is 0, you will be directly getting the value for your s1 equal to 6, x2 equal to 12 directly there. So that is quite okay. Next thing is initial iteration. Initial iteration means the initial simplex table is given by like this. Initially you have to write Cj and all this thing corresponds to the value of the objective function. What are all the coefficients we are having in objective function? 21, 15, 0, 0. So that values you have to enter it here. And this in this first column CB, YB, XB. So CB all the time for the initial iteration it is going to be 0. And YB means how many variables you have introduced. S1, S2 means that you have to write out. And what are all that corresponding values? 6 and 12 we have got. So that we have to enter it here. So this is the first 3 column. And in your X1, what is the value for your X1 we are having means 1, 4. x2 means it is 2, 3. S1 means in the first equation, your S1 coefficient is 1. S2 coefficient is 0. Similarly, in your second equation, your S2 value is 1 and S1 equal to 0. So all these things we can enter it by from the given two equations itself. And you have to find out your ratio value. Before finding the ratio value, you have to take your ZJ value. ZJ value means initially all the ZJ values are 0. You have to assume it like that only, because if you are multiplying 0 into 1 plus 0 into 2, you will be getting 0. Since the CB value is 0, if you are multiplying 0 with this element and adding also, you will be getting definitely 0 only. That is 0 into 1 plus 0 into 4. It is 0. 0 into 2 plus 0 into 3 equal to 0. 0 into 1 plus 0 into 0 is 0. Similarly, 0 into 0 plus 0 into 1 is 0. So all the part is going to be what means Zj equal to 0. And similarly, if you are coming for Zj minus Cj means this Zj value you have to subtract from Cj. So that is from Zj you have to subtract Cj. 0 minus 21 is minus 21. 0 minus 15 is minus 15. 0 minus 0 is 0. 0 minus 0 is 0. So all the things are going to be 0 here. Among the Zj minus Cj, you have to see which one is most negative. That is highest negative value is minus 21. In this we have to keep it. Similarly, you have to divide this corresponding x1 with xp. All the values by xp. How can we divide that xp means you have to divide xb minus x1, 6 by 1, 12 by 4. In this one, you see which is minimum. So this row you have to take it and this column you have to take it, and this point of intersection is nothing but a pivot element. That is, once if you are choosing the ZJ value, that column you have to keep it properly, and this ZJ value you have to keep it. That is, this ZJ have to be divided by this corresponding variable. In case of your most negative value is here, means this column and this column you have to divide it. That is xp divided by x2, xb divided by x3. Likewise, you will be having. In this one, you have to see which is the point of intersection for both. So for minus 21 and 3, which is a point of intersection for both, you will be getting that one as what means your pivot element. Okay, that you have to keep it as what means 1, and all the other remaining elements corresponding to that column must be take it as what means 0. Thus this 4 you have to convert it as 1. How can you convert this 4 as 1? If you are dividing this row throughout by 4, definitely you will be getting the value as what means 1. So 12 by 4 is 3, 4 by 4 is 1, 3 by 4, 0 by 4, 1 by 4. So this entire row has to be divided by 4. And you will be getting this equation, this value as 1. And the elements below and after this 4, you have to convert into what means 0. So already below this 4, you are having 0. So above this 4, what's the thing we are having here means 0. 1, that you have to make it as what means 0. So that is our next thing. How we have to convert that one here means what we have seen in that previous thing only we are seeing it here also. Since J minus Cj equal to minus 21 is most negative, the corresponding non-basic variable x1 enters into the basic, and the leaving variable is the basic variable which corresponds to the minimum. All these things, what I have explained here only, it is given as. And already I have told you know that 4 has to be divided by 4 only to get the value as 1 in that corresponding place. And if you want to convert that 1 as 0, that 1 you have to convert it as 0 means you take that old equation, which equation you have to make it as 0, that you take it and multiply 1 with this new pivot equation, and then subtract, you will be getting automatically the second place as what means 0. Automatically you will be getting that second place as what means 0. So this is one equation also there. And if you are getting that one means you will be getting that value as 0. And if you are dividing that throughout that equation means you will be getting that place value as 1. So now you can calculate Zj. What is your Zj? 0 into 3. plus 21 into 3 equal to 63. 0 into 0 plus 21 into 1 is 21. 0 into 5 by 4 plus 21 into 3 by 4 is 63 by 4. So if you are multiplying and if you are subtracting Zj minus Ej value means all the values what we are having here is non-negative. That is all the values what you must get here is nothing but the positive values only. So all the values we are having here is only positive. Since you can stop the problem by that one itself. That is you have to say which is a j minus ej is greater than or equal to 0, and according to that you have to choose your pivot element was also from there. So Zj minus Ej, you have to see which is the most negative corresponding to that one, and you have that entire column must be divided by xb. If you are taking this last column, you have to find out the point of intersection. Here they are represented by the arrow mark, and in this arrow mark you can point out or you can circle this element. That element is nothing but called as pivot element. That element you can directly convert into 1 by dividing the equation by 4, and above to that one you have to make it as what means 0. So that's the thing you have to here. So this is the first iteration. And in your second iteration itself, you are getting all the Zj and Cj are greater than or equal to 0. There is no negative value in that one. So therefore, the optimal solution is what's the value you are getting for your x1 means, and x1 value is nothing but what here. Here you see x1 value is equal to 3. But in that yb, there is no x2. So you are not having x2 means your x2 value